7, surface area and volume, prism and cylinders. You should have already seen all this stuff. It should make sense to you. When you talk about prisms, just in general, a prism is any shape that's matched on the top and the bottom with rectangles around it. That's a prism. So for example, if you have a triangle on top and bottom connected by rectangles, that's a prism. If you have a hexagon that has lines all the way down to the next hexagon but makes a bunch of rectangles around, that's a prism. Okay, so prisms are essentially two bases connected by rectangles. Okay, so when you look at these, you have the triangular prism. That's what I'm talking about. Triangle top and bottom, it's connected by lines, which makes rectangles around it. Okay, same thing here. This is a rectangular prism, so it's got a rectangle top and bottom, and it's connected by rectangles all the way around. And then you have a cube prism, cube on top and bottom, connected, okay, all the way around. Okay, those are what prisms are. Okay, so the key is prisms are made up of rectangles. The basis can change. Any questions on what a prism is? Okay, so in general, volume of a prism is simply the area of the base, whatever the base is, times the height. You have a triangle, area of the triangle times the height. So for those of you guys doing your ramp, to find that volume, it's going to be the area of the triangle on the side of it times the length of your ramp, right? Like the footstep length, okay, the width, if you will, of your ramp. Because your ramp is essentially a triangular prism. Okay, your ramp has, if I go up here, your ramp is essentially, if I turn this will be the ramp piece, for example. That side piece is the base. So you have triangles on both sides of your ramp. That's essentially you have a triangular prism is what we're talking about with ramps. Okay, so in general, you would take the triangle times that, the height or the width of your ramp. Okay, so the volume is the area of the base times the height. Surface area kind of varies depending on the shape, but essentially it's the area of the two bases added up, and then the area of all the rectangles around. So for example, how many rectangles are in a triangular prism? 3, right? 3 sides. 1, 2, 3. I have those 3 triangles I got to figure out. Okay? Any questions so far? This should be kind of a somewhat review, but I'm going to go a little bit quicker so you, like I said, get some time. So then when we get to the formulas, so in general, we're talking about perimeter of these figures. So we know the perimeter of a circle is essentially called the circumference, right? Distance around the circle, that's the circumference. 2 pi r is that formula. Okay, you get these formulas. They are formulas. I don't need you to memorize those. Okay, then here's the other ones just for, you probably know these 4 really well. These 2 might be a little bit foggy. So rectangle, base times height, very simple. Square, s times s, so s squared. Parallelogram is the height of the parallelogram, so not the slant, but the height times the base. Okay, triangle, half base times height, or base times height divided by 2. Area of a circle, pi r squared. Trapezoid, again, a little bit difficult. Half of the height times the 2 bases added up. So the height, 2 bases. So half of the height, a plus b, the 2 bases. Okay? All right, so let's do one of our examples here. So, So consider the right triangular prism shown. Determine the base of the prism. So the area of the base of the prism, first off, what is the shape of the base? Triangle. Good. So we need, so if you just go, okay, I'm doing a triangle. I need the area of a triangle, which is half base times height. So then we go and see, what do I know? Do I know the base? Do I know the height? What's the base? Okay, so the base, what's that? What's the height? Nope, 6 is this height. We're talking about just this triangle here. Okay, what's that, Jake? Yeah, use Pythagorean theorem. Hassan?
For the test, would you have to memorize all these? Or
Those should be, you should know, I would say you definitely know the 4 on the left. Okay, but the ones the 2 far right you would get. You're probably going to get all of them, but you should know the 4 on the left. You should know circle, you should know rectangle and triangle. Okay?
this is the triangle.
Okay, so it says determine the area of the base of the prism. So it says base of the prism, guys. The base of the prism is a triangle, top or bottom, doesn't matter which one you use. That's the base of this prism because that's the shape of the prism. It's a triangular prism. Okay, so 10 is the base. That's correct. So I have 1/2 times 10. I don't know the height. I know this is 13. I know this is 5. How did I get 5? Right, because it tells me these two are equal. Those little ticks there mean they're equal. That means I can split it in half. Which also means this, what kind of triangle is this? Good, which means 13's over here too. Okay? So, what we know is this is 5, this is 13. Pythagorean theorem, that's grade 8. We should be fine with that. 13 squared minus 5 squared equals my height squared. 13 squared the hypotenuse minus the leg equals the other leg, which is the height. 169 minus 25, 144, square root, height is 12. So now we have to find the area of the triangle, 1/2 10 times 12. You're going to get 60. The area of the triangle is 60 square centimeters. Surface areas in square units, volumes in cubic units, right? Cubics filling it up, surface area is painting it. So now determine the volume of the prism. We don't have much work to do here because we already have the area of the base. We just need the height that Colin said, the 6. We need that now. So for volume, remember volume of the triangle is base times height. We got the base right here is 60. So volume of the triangle is 60 times 6, which is 360 cubic centimeters. Questions? Yeah.
So once you have, like, the top one is in squared units,
Mm-hmm.
and that one's in only just regular centimeters, that changes into cubic centimeters?
Right, because of volume.
Okay. But if you're, in the sense of us doing it though, like, the centimeters squared for the area, when you multiply that by regular centimeters, that makes it?
Correct. Yes, essentially yes, because you're doing centimeters squared times another centimeter about. Yes, that's a good way of looking at it. You have, yeah, with exponents it's 2 and 1, right? Yep. Okay. Next thing, we're gonna do the surface area. So the surface area, you already know these two pieces. They're both 60s, right? So you can write those down. How many pieces total are there? 1, 2, 3, 4, 5. Correct. There's 5. So our two pieces, we have a 60 plus a 60. That's my triangles. I'll draw little triangles here. Now my rectangles, I have actually two rectangles that are also the same. I have two 13 by 6s. 13 by 6s. See these outside slices of the pie there, or cake? They're both 13 times 6. And the last piece is what? This little piece here? 10 by 6, another 60. Good. Okay, so we just add all those up. That's my surface area in square centimeters. So I have 180. Okay, it gets us all the way to 336 square centimeters. Any questions with that? Okay. Okay, so here's a couple of conversions. Again, you don't have to memorize these. It's just they are conversions from going into lengths into liquids. So for example, cubic centimeter is equivalent to 1 milliliter. 1 cubic centimeter is 1 milliliter. Okay, so 1,000 milliliters is 1 liter. So, grand scheme here, 1 liter of milk is 1,000 cubic centimeters. Okay, it's just a conversion. Don't be confused by it. It's just crossing over from like a box measurement to actually the liquid that could go inside. Because we recognize liquid as being liters and milliliters, right? Okay, so that's just a conversion for you. Then you got the awesome imperial that's not nice numbers. Okay, so 1 US gallon, 3.7854. 1 imperial gallon, 4.5461. And the 1 gallon equals 8 pints. Just, okay, those are just some conversions to keep in mind for questions later, but you get that. You don't have to memorize it. Okay? So again, you have your solids to your liquids, okay? So this is imperial, metric. So look at this question here. So I think this is receptacle included. We said it earlier, it's kind of weird to say to me for some reason, but it's a manufacturing company that makes containers of various sizes. from materials such as corrugated cardboard, metal, glass, plexiglass, or plastic. 2 companies asked Receptacle include to produce containers of the same size and shape with right rectangular prisms. 1 company, Cubicle, needs a plastic container 15 centimeters by 10 by 8 high in which they pack their 1 centimeter sponge cubes in. Okay, so they just need an open container. Waterworld Aquariums needs the same exact size, but they want to fill it with water to transport their samurai fighting fish. Okay, so first off, it says calculate the volume of container for the Cubicle company. Is cubic centimeters the right unit, or do we want to go liters? For the first company that they're going to be putting a sponge inside, do we need to know a liquid? Yeah, we don't need to know a liquid filling, right? We're not filling it with liquid. We're putting a sponge inside. We need to know space. Does that make sense? So the first one, cubic centimeters, is okay. Just put space, because it's space, not filling with liquid. So what that would be is 15 times 10 times 8. So that'd be 1,200 cubic centimeters. We just put cubic centimeters is okay because it's space we're putting something inside. Now the other place, obviously, we're putting water in it because we're transporting fish. So therefore, we'd like it to be in liters of water. Like how much water are we going to put in there? Okay, so how much space the water can it hold? So we go back to our conversion above. If it's 1,200 cubic centimeters, what is that in liters? Yeah. 1.2. Okay, if you're not sure how we got that, we know 1,000 milliliters equals a liter. We know that 1 cubic centimeter equals 1 milliliter. So all we had to do is take our 1,200, because if it's going to be 1,200 milliliters of water, because we have 1,200, they're the same, right across, 1 to 1. And then to figure out the liters, we divide by 1,000, because there's 1,000 milliliters in a liter. 1.2 liters of water will fit in there for the fish. Then it says to put it into U.S. gallons. So to U.S. gallons, we can use our unit analysis. We can go 1.2 liters over 1 times 1 gallon is 3.7854. So see the unit analysis, I have my L's to cancel. My L's cancel, I'm left with gallons. And so we simply are going to go 1.2 divided by 3.7854 because the ones don't count, or they don't really affect anything. So in gallons that you need for the fish is 0.32 gallons. And that would be US gallons. GAL. Okay.
What's in the side gallons?
US. Sorry, parentheses US there. Yeah, it looks pretty horrible, sorry. US. Gets a little, I don't know, my hand gets a little shaky in the bottom right pretty bad. I'm not sure why. Getting old, I guess, maybe? I don't know. All right, so now we're moving on to cylinders. Okay. I know a lot of you guys in my Math 9 class, you did the surface area project. A lot of you guys had a lot of cylinders in your surface area project. So just to refresh, and I showed this in Math 9, but again, if you take a piece of paper and you roll it up, okay, take a piece of paper and you roll it up, you make a cylinder. Okay, so I have simply a cylinder, no problem. And the reason this is a nice illustration is that we know if I cut this now and I unfold it, it now makes that rectangle. So understanding that the wraparound of your cylinder is a rectangle is important, but you need to know what is this of that wrapper. That's the circumference because that's the part that went around the circle, right? So that was my circumference. This is just my height. So circumference times height is all you do for your wraparound. That's what this is. See how this have this rectangle here? So it's height, circumference. So you go height times 2 pi r. So essentially it's 2 pi RH. 2 pi RH all multiplied together give you that rectangle of the wraparound of your cylinder. Okay. Otherwise, your surface area is also the wraparound plus the two circles. So you have three pieces. One circle, two circles, the wraparound. Pi r squared, pi r squared. And that's why right here is the formula. Two circles plus the wraparound. 2 pi r squared plus 2 pi r h. Okay. Okay, and they just said use the formula up at top, so just, I mean, it's a little bit tedious, but it's pi r squared plus 2 pi r h plus pi r squared. These are like terms, so that's how they made that a 2. Pi r squared plus pi r squared is 2 pi r squared. Okay, that's for surface area. Volume, it's not any different than before. How do we find volume of the cylinder? Yeah, the area of the base times the height. You say area there, I know you meant that. Yeah. Okay, so general formula to find the volume, it's going to be pi r squared, that's the area of the base, times h. Just the area of the circle times the height. Okay, and then they have those formulas for you right below. Okay, and we just have some examples and we're done. All right, so let's go ahead and put this to work now. All right, so next last page here. So calculate the volume and surface area of a cylindrical can whose height's 15.4 and base diameter is 10.2. So what that looks like, it's going to be, you have a can, okay, and you have 10.2 is the diameter, 15.4 is the height. So I want the surface area and the volume, so I know my surface area again is going to be 2 pi r squared plus 2 pi rh. So I need r though. I have diameter, so I had to make that little quick, cut it in half, right? So what's my r? Yeah. Yeah, 5.1 is my r. So guys, it's simply a calculation, okay? That's all we have to do now. It's going to be 2 pi 5.1 squared plus 2 pi 5.1, height 15.4, and you just calculate that. That's all calculated right there. Okay, that's it. When you calculate that surface area, you should get 659.9 squared centimeters. Okay. All right, volume we know is pi r squared times height. Just insert it. Pi 5.1 squared times, that's a times there, 15.4. When we do that, you get 1258.4 cubic centimeters. These next couple are almost like too easy in terms of you people are overthinking them, but all right. So it says a commercial garbage can or bin is in the shape of a cube. It has the volume of 60.24. Has a volume of 60.24. How can I find the side length? Yeah, Chloe? Just cube root it, because all three sides are the same. A cube is 3 sides equal. So simply take this number and you cube root it. That gives you 3.92 meters. If it's 3.92 meters, they want the answer in centimeters. So how many places did I move the decimal? 2 to the right, so 392 centimeters is the side length of the garbage can. So the garbage can is 392 by 392 by 392. Okay, did I say something too fast? Are we good? So it was a cube garbage can, So we cube rooted to figure out what one of the sides was in meters. We converted that meters to centimeters by moving the decimal 2 spots to the right. Okay, so we got 3.92. So you got your cubic garbage can, however, here. So that means it's 392 here, 392 here, and then 392 here for the height. That's all we figured out. Okay, the box, so if you've seen these at the store, you might have as well. The Tollerborn or whatever chocolate bar is in the shape of a triangular prism. So they come in like little cardboard tubes there that are triangle bases. So triangular faces have a base of 3.7 and a height of 3.2. If the space in the empty box has this volume, what is the length of the box? So we're given, so we know the volume of a triangular prism would be area of the base, so A times, we're going to call it length even though it's height, but they're calling it length so we don't get our heights confused because there's two heights, the height of the triangle. Okay, so we know the volume, so we put that in for V. 123.7, that's my volume. Okay, how do you find the area of that triangle? It'd be half base times height here, times, I'll call L length again because they asked for length. Even though, guys, it's also known as the height of the figure. So we simply just times 3.7 and 3.2 and a half. Can you get that for me, Nikki?
It's 5.92 is the final answer for that area.
Right here? Okay. 5.92. So that means we have 5.92 times L, and then we divide by 5.92 is all. Yeah, it's 20.895, so we're going to call it 20.9. So the box is 20.9 centimeters long. So just for what would we want to do if we want that in inches, what would we do?
Multiply by 2.54.
Divide by 2.54. Inches are bigger than centimeters.
Oh, yeah.
So you divide by 2.54. Okay, last example here. This one's really actually quick, and we'll be done. Okay, poster company has decided that all the posters will be shipped in a cylindrical container with a height of 17 inches and circumference of 2 inches. The curved surface area, so the part you're wrapping around that cylindrical container, this piece here, okay, will be wrapped with paper label containing the company logo. Calculate to the nearest square inch the curved surface area of the wrapping container. So what is the wraparound of the containers? That's all we're trying to do. Well, they already give me circumference, and alright,
It's so easy.
yeah, they already give me circumference. Because remember, it's circumference times height, right? Yeah, it's just 17 times 2. 34 square inches is the surface area of the wraparound. Okay? All right, so that's it. 1 down, 2 to go for your Math 10 career.